Welcome to Lab 8 on Angular Magnification. We're going to start out with the emmetropic model eye, so we want to auto-collimate the +5 diopter lens. You're pretty used to that. Got parallel light coming down the optical rail, and we have a +10 diopter lens, and the screen acting as the retina. Now the eye is accommodated, +3 diopters of accommodation, or whatever your 3 diopter lens measures out to be. And I found a clear image on the retina that corresponds to viewing the near point. So the object is now the light source. We don't have the intermediate lens anymore. We just move the light source to find the near point. And we've got that clear viewing condition set up here. You're going to carefully measure both the object and image distances here, as well as the object height. So pick a part of the object to measure, like the full height of the arrow, and then measure the full height of the arrow on the image as well. Flexible ruler can help, or you're welcome to turn the screen around or use a card to measure that directly. Again, measure the same part of the object. So if you're going to measure the full height of the arrow over here, measure the full height of the arrow and the image as well. That retinal image height is going to be an important value to write down. So write that in your notebook, label that reference retinal image height. You're going to compare to that a lot throughout the lab. If it's helpful, you can write that in Sharpie marker on your partner's forehead, just so you don't forget that number. It's an important number. So retinal reference image height. Keep track of that number. Now we have less accommodation, only 2 diopters of accommodation. So I'm gonna have to move the light source farther back and then locate a clear image for this amount of accommodation. And again, we'll wanna do the same measurements. Measure the object distance, object height, image distance, which should be the same as before because it's the eyeball, and then image height. So on the retina, the retinal image height. And now you'll compare that retinal image height to the reference retinal image height. Read your partner's forehead if you need to. Reference retinal image height is your comparison value. So current viewing condition compared to previous viewing condition. That's how we do angular magnification. Since all we did was move the object, this is relative distance magnification. Since the only change in between the 2 viewing conditions was object distance, this is relative distance magnification. For part 3, we're using a simple magnifier. We've gone back to the unaccommodated eye, just the plain +10, same retinal distance, don't move these for the lab, and we've put in a simple magnifier. This is now a +7 diopter lens located 5 centimeters upstream from the eyeball. You're going to have questions to answer about what kind of rays you expect between these 2 in order to find a clear image. Conversely, that's asking where is the object for the eye? Where do you want the magnifier to place the object for the eye? So think about where its image is going to form. And then predict that, calculate that, and then see if that compares to your actual results. So you'll move the light source to again find a clear image. That's now a clear image on the retina. And once again, you're going to measure that retinal image height and compare that to your reference retinal image height to calculate angular magnification due to a simple magnifier. Now finally, we're using the magnifier with an accommodated eye. So I've added the +3 diopter lens back into the eye to model accommodation. And now in this situation, you want to think again, where should the object for the eye be located in order to form a clear image on the retina? And then use the divergence equation with the +7 diopter magnifier to figure out what object the magnifier should have in order to form a clear image in the eye. And then go ahead and test that. Locate the clear image with moving the light source around, find the clear image on the retina. And then once again, compare that retinal image height to your reference retinal image height from the very beginning. And that ratio that you can use to find angular magnification for this viewing condition. Again, comparing this viewing condition to the very beginning where you had the light source at the near point.